Hi, dear participants. Thank you for being here today, and it's a pleasure to present our study titled Design of a Web Based Modular Self Assessment System for Educational Portals. In this presentation, I will briefly discuss the introduction method, development of item pools and pilot testing, architecture and development process of the self-assessment system, question management interface, audio management interface, question system interface, and finally the conclusion, and then I will finish my presentation there. Web based learning environments have become much more than simple platforms for content delivery. Today, they are expected to support interaction, learning, analytic, feedback, and assessment process in an integrated way. In such environments, assessment is not only used to measure performance at the end of instruction, but it's also to guide learning, make progress visible, and support learners' awareness. At the same time, modular instruction has become an important approach in digital education. In modular systems, content is organized into independent but related units, and learners can progress step by step according to specific learning objectives. However, for such a structure to work effectively, each module should also include an assessment component aligned with its intended outcomes. From this perspective, self assessment systems are especially valuable. They allow learners to evaluate their own knowledge, readiness, and awareness while also generating useful performance data for instructional decision making. But for a self assessment system to be meaningful, it must be strong not only pedagogically but also physiometrically and technically. Item quality, reliability, discrimination power, and system usability and all matter. Based on such kind of needs, our study focuses on the design and development of a web-based modular self-assessment system integrated into an educational portal. The system was structured around 8 instructional modules and aimed to provide a scalable digital assessment infrastructure supported by item development, pilot analysis, and system integration. This study was designed as a descriptive research based on a design and development oriented approach. The purpose of the study was not to test the effectiveness of the system experimentally, but to describe the full process of designing, developing, and refining a digital self-assessment system from both pedagogically and technical perspective. Within this framework, the study included a sequential and iterative process composed of several stages. First, assessment content was prepared in line with the principles of measurement and evaluation. Then, item pools were developed for each module, and after that, pilot implementations were included and item analysis were performed. Then problematic items were revised or removed, expert feedback was gathered, and finally the assessment system was integrated into the digital portal. So the method of the study reflects a systematic development cycle in which educational content, physiometric quality, and technical implementation were considered together. Now, I would like to explain the development of item pools and pilot testing process. For each of the 8 modules, a comprehensive item pool consisting of approximately 45 to 70 items was developed. These items were prepared in direct alignment with the learning objectives of each module. The aim was to ensure that each assessment reflected the targeted competencies, knowledge areas, and awareness dimensions of that specific module. After the initial item pools were created, Pilot implementations were conducted with groups of approximately 17 to 20 participants. The data obtained from these pilot studies were analyzed using the Test Analysis Program or TAP. Through this analysis, the measurement properties of the items were examined in details. In the item analysis process, several criteria were taken into account. We examined item difficulties in order to avoid items that were too easy or too difficult. We also evaluated item discrimination to determine whether the items could distinguish between high performing and low performing individuals. In addition, corrected point biserial correlation were used to examine the contribution of each item to, to the overall measurement objective. And another important aspect was distractor analysis. Incorrect options were evaluated to see whether they were functioning properly. Non-functional or logically weak distractors were identified and revised or removed. After this analysis, the remaining items were submitted to subject matter experts for review in terms of content validity, clarity, and alignment with the intended objectives. Based on expert feedback, the final revision were made at the end of this process. As a result, final assessment sets were established for all 8 modules and integrated into the self-assessment system. This process strengthened and physiometric quality of the system and ensured that the assessment content was both educationally meaningful and technically ready for implementation or to work on it. And the next major part of the study is architecture and development process of self-assessment system. The system was developed with an educational portal consisting of 8 modules, as we said before. And from a technical perspective, the self-assessment system is built on a modern client-server architecture. The system has 2 main layers: the backend layer, which handles business, loggage, data management, authorization, and API services, and the front-end layer, which is responsible for user interaction and interface presentation. On the server side, the backend was developed using Express.js, which was selected because of its lightweight and high performance structure. The system provides communication through RESTful API endpoints. For example, assessment questions and use related operations are delivered through API based communication between the server and the client side. The study also emphasized the role separated architecture. In this structure, the creation and management of assessment content are handled through the admin panel, while the actual assessment experience of the end user is managed through the Laravel based main system. This separation makes responsibilities clearer, supports maintainability, and reduce technical complexity during integration. So, overall, the system architecture were designed to be modular, scalable, secure, and sustainable, while also supporting the educational measurement principles. And question management interface. It's one of the key administrative components of the system. It was designed to allow administrators to create, edit, organize, and manage assessment questions efficiently. Since the self-assessment structure is based on multiple modules, question management needed to be systematic and flexible. And throughout this interface, administrators can prepare assessment content for each modules separately. They can enter question text, define answer options, organize items according to module structure, and ensure that the questions are properly integrated into the system. This makes the interface essentially not only for content entry, but for the operational sustainability of the assessment process. And question management interface supports the backend structure of the system, by the way, by serving the as the main point where item content is prepared and updated. In this sense, it acts as the bridge between item development and digital implementation of the research. The other one is audio management interface. The interface was included to support the management of audio based materials associated with the assessment system. In digital learning and assessment environments, audio can be an important supplementary component, especially when the goal is to provide the richer, more accessible, or multi modal learning experiences. Based on this, the system structure described in the study, audio content is managed through a dedicated interface within the administrative framework. The presence of a separate audio management interface shows that the system not limited to text-based item delivery. Instead, it was designed with the flexibility to manage different types of content and media elements with the portal structure. For example, when you see the questions, and also you can listen the questions in the same time if you push a button and then you can listen the question. In the question system interface, in a developed structure, I mean, question delivery process is handled on the client side. This means that how the questions appear on the screen, how users navigate between them, and how interaction is managed are all controlled by the user facing application layer. This provides flexibility for integration into different interfaces and platforms. System also includes a self-assessment and results page, which appears when the user answers all questions or chooses the finish test option. This page summarizes the user's performance and provides feedback according to a predefined threshold. We know that feedback is very important in education systems. If we want to name the system as system, we need feedback in that point, and our question system interface handles that point of the research in that point. And our study presented the design and development of a web-based modular self-assessment system integrated into an educational portal. The system was developed to evaluate learners' knowledge levels, awareness, and readiness throughout a structured model-based digital assessment framework. And the study showed that the development of a strong self assessment system requires attention to both measurement quality and technical architecture. On the measurement side, pilot testing, item analysis, distractor with review, and expert evaluation helped improve the physiometric quality of the final item tests sets. On the technical side, the modular portal structure, client server architecture, RESTful API communication, and separated administrative interfaces create a sustainable and scalable digital infrastructure. Overall, the findings suggest that the developed system is not only technically functional, but it also educationally grounded and suitable for use in modular learning environments. At the same time, I need to add that the study has some limitations, especially the relatively small pilot groups and the absence of experimental testing of long-term learning outcomes. So, future studies may involve larger samples and experimental designs should be added maybe, and more advanced approaches such as item response theory and learning analytics should maybe needs to be added to the research. And here we reached the end of our presentation, and I hope that my presentation has been useful for all of us, and thanks for listening to all our participants.